on 2.1, when we talk about the the domain and range of the function, do you remember from like algebra, okay, algebra 2, what is the domain? What are the values of the domain? It's okay.
I know, but I don't know.
So we usually associate the domain with the x values, okay, and the range then would be then the y values. Okay, and now keep in mind, domain and range is just what you're inputting into the function, your function versus what you're inputting your function. And if you kind of go even back a little further, when you started talking about function machines, probably in like, oh my gosh, probably third or fourth grade, when we put a number into a machine and it spits a number out.
Oh yes.
That's the elementary part of that beginning of those functions. And we talk a little bit about the domain and the range. Now, the relationship is any set of ordered pairs, okay? And so remember, when I think we've talked about this too, when I look at the point 7, 9, then 7, 9 is my x value and then my y value. And in the way if you struggle for remembering which one goes left and right and which one goes up and down, this is also alphabetically. Well, cool, huh, right? So my x-axis will always be my horizontal axis, my y value is my vertical axis. And so, now, when I talk about the domain and the range for each relationship, then on this one, if I go my domain, then on this one, all I'm doing is writing out my x values. And so in this case, my x value for this point was 7, this one's 7, and this one's 7. And so that my domain then is just the set that includes only the number 7. Now, when I do my range, then I'm looking at the y values. And so my range would be 9, 10, and 11 in this case. When I look at the next one, the domain is going to be then, in this case, it's going to be the 4, 5, and 6. Oops, bracket. And then the range is the same. And so it's the 4, 5, and 6. And now, in this case, when I look at whether or not we have a function or not, when I look at this value here, if I plot these points, and I said that x is going to be 7, 9, 7, 10, and 7, 11. This is an example where it's not going to be considered a function, so this one is just a relationship, and it's because of the fact that the x value is paired with more than one value. Now, it can be the opposite. In other words, if I had this switched around and it was 9, 7, 10, 7, and 11, 7, where the range was actually the one that repeats, but the domain was separate, then that changes it to a function. This is also considered a one-to-one function because of the fact that every member of the domain is paired with a unique member of the range. If I go back then to introducing a function, again, the function is the correspondence from which the first set, called the domain, to the second set is called the range, such that each element in the domain corresponds to exactly one element of the range. So in this case, this is going to be considered a function because every member of the domain, let me put the domain, and every member of the range has a unique pair. Now, this one's not considered a function because this would be the similar if I had 1, -1, 1, 1, and what happens, it's going to be then it'll pass what we call that vertical line test, which we're going to talk about in just a second. So back to the two examples that we had. Remember, this one is not a function because when we paired this together, the domain would be paired with 3 different values. And so this one's not a function, where this one is a function. Excuse me. So when on an equation, if you solve the equation for x and check to see if one or more of the values of y can be obtained for a single value of x. In this case, this one, if I solve it for y, I'm going to have y equals, I'm going to move my x to the third the other side, so it's going to be x to the third. And that means that no matter what I put in for x, I get a unique member for y. And this one is going to be an example of a function. This one, however, is not, because remember, if you think about it, when I solve for y, if I have y squared is equal to x, and then I take the square root of both sides, remember, then this would be then y equals both positive and negative x, and this would be an example where that's paired with, the y is paired with two different values of the x. And so when you do think about functions, think about the fact that what makes it a function and what not. And if you can find two values where you can have one value for y but two values for x, then you're going to know that that would be and would not make it a. So on this one, it says now substitute the various values. So what we're doing is we put a couple values into those functions, and if you can find any one that you can that makes it false, then you know that you do not have a function. I like the vertical line test. To me, it makes sense to me because I guess probably because I'm a little bit of a visual learner, that does help. But in this case, if I can draw a line anywhere on my function, okay, and it only passes, that vertical line only passes in one place, then I know that I have a function. So even when I reflect back by putting in my numbers here, you know, when I look at the fact that I have the x equals y squared, which is right here, before I solved it for y, then it means I had an inverted parabola that looks a little bit like this. And so I know that this one would fail the vertical line test, and that shows you with the points that you would substitute in. And so this would be an example of where you'd have x equals a y squared. Now, it's helpful to know some of our functions, our common ones. Goodness, I've got a frog in my throat. Do you know what this one is? What would that graph as? If you have an x squared and a y squared, that's a clue. And the fact that they're both positive, this is going to be an example of our circle function. So this is in the form, we're going to talk about circles later on in the year, but this one actually has a center at 0, 0, and it's always going to be the radius will be the square root of what it's equal to. So this one looks like, with a radius of 3, it looks like this as a graph. And honestly, another way to test sometimes is use Desmos. Desmos is a online graphing calculator that you can just type in, put that function in, and it'll also tell you. But in this case, this one obviously would fail the vertical line test in multiple cases, and so this one is not considered a function. The key here a lot of times is that squared, okay? So if the y squared is the y is squared, then be careful, because a lot of times that will make it not a function. Okay, then it says use the vertical line test to determine whether the graph is a function. Well, obviously this one is going to fail. No, it is not. But in this case, a linear equation will always be a function because there's no vertical line I can put there, so this one's always going to be a yes. So again, linear equations have a value where y equals is y to the first power and also x to the first power. So like when the equations y equals mx plus b is a very standard form of that, and beginning where m is going to be your slope and y is going to be your intercept. And in this case, if the power for both of those is the first power, and so that's also another clue that has to be a function. The next one, special notations for f of x. So when I have the value of a function that's in terms of x, usually it's written as f of x, and this is how you say it. Now, it doesn't have to always be f. It can be any letter that you want. But the common one, the most common one, is going to be then f of x. And what this is, would be the input of the function is simply a result of the output of the function. So when I look at f of negative 2, if I've defined my f of x as x squared minus 2x plus 3, and I want to find f of 2, then that means that wherever I see an x, I'm going to replace it with a negative 2 and do that same operation. So in this first one, if I'm squaring x, that means I'm going to put negative 2 into my function and square it. Now be careful, because in this case, this first one, I'm going to take a negative 2 times negative 2. And that is different than if I have f of x, if I write negative 2 and squared, okay, This is actually going to be 2 squared that makes it negative, and this is not the correct way to substitute that back in. So I'm going to start off, I'll have negative 2 squared. I'm going to go minus 2 times negative 2 plus 3. And so then the next step is going to be to go ahead and use those operations. So negative 2 times negative 2 would be 4. Right, a positive 4. Then I have 2 values. I have really a negative 2 times a negative 2 again, and that value is going to be positive, so I want to go plus 4 and then plus 3. When you put this into your calculator, if you like to go from the start to the finish, make sure that you have the parentheses around your negatives for your squareds. And then the last one, this one's quick. 4 plus 4 plus 3 should be then the value of 11. 8 plus 3. Now, I can also substitute a function within a function. Okay, so my function here is going to be x plus 1. And so that means wherever I see an x in my original f of x, that means I'm replacing it with x plus 1. So that means I'm going to have x plus 1 expression squared minus 2 times x plus 1. And then I'm going to go plus 3. Now remember on this one, if I have x plus 1 times expression squared, that means x plus 1 times x plus 1. Okay? That's what that is interpreting. So then when I multiply these together, I want to make sure that I get all 4 terms. Okay? So I have x times x, which is x squared. Now I know that you guys are getting better at this, but if I go x, I'm going to go plus x plus x. If you want to jump ahead and just automatically in your head go, okay, I've got x plus x, that's 2x, and just write the 2x here, that's fine. But then I have plus 1. Then I'm going to go ahead and distribute my negative 2 into my parentheses, so I'm going to have a minus 2x, but remember I'm going to take a negative 2 times the positive 1. So it's going to be a negative 2 and then plus 3. And then the last step here is to go ahead and just combine all your like terms. I only have one x squared term, but I have an x plus x, which is 2x, but I have a minus 2x. Those actually all cancel out. And then I have a 1 minus 2 plus 3. So a 1 minus 2 would be a negative 1 plus 3, then it gives me positive 2 again. So my function f of x plus 1 would actually be f of x equaling x squared plus 2. Questions on that? Okay. The last one, and don't you love how I left enough room for all this? So anyway, I'm going to start off, I have f of negative x. That means I'm going to replace the negative x inside. So I'm going to make sure I go a negative x expression squared. I'm going to have minus 2 times negative x, and then plus 3. Now, when I take a negative x expression squared, that's really it's like I have a negative 1 in front. Well, negative 1 squared is just going to be positive, and so this is going to be the value then of just a positive x squared. When I take a negative 2x minus x, what value would it have? Positive or negative? Positive, yes. And then I have plus 3, and then that's as far and as simplified as I can get it. We also have done absolute value functions on the last chapter, so hopefully we can get it. And we start off with the parent function, and then we're going to actually have a shift, okay? And so in this case, when you have a plus 5 on the outside, that's going to tell you that you're going to have a vertical shift. If you remember from chapter 1, we started off with x and then y, and if I'm going to do g of x, then what happens is we start off with negative 3, negative 2, negative 1, 0, 1, 2, and 3. And if you remember, that's one of the questions we have on our test. But in this case, I'm going to still just go ahead and go a negative 3, the absolute value of a negative 3 plus 5. And then so it end up being then 3 plus 5, which is going to be 8. And then what'll end up having it when I'm jumping down, I'm going to have 0 plus 5 is equal to 5. And then the last one, when I have 3, I'm going to have the absolute value of 3 plus 5 is equal to 8. So again, when I plot this, I'm actually going to shift. My parent function, f of x, was really one that I'm just going to do it in like little dashed marks. Okay? So it's this parent function that actually just shifts then up 5. So if you have something that's either added or subtracted to your function, then that's just going to be a vertical shift. So that means I'm going to take every one of these values and I'm going to move 1, 2, 3, 4, 5. And then remember that was 0, 5, which is what I had from when I plotted my 3 points in. But then when I have 1, 2, 3, I'm going to have then 8. There's 5, 6, 7, 8. And so my actual function of g of x will look a little bit like this, where it just shifts up. Questions on that? Perfect. Okay. Now, the next one, use the graph of the information at right to obtain what g of negative 4 is. So g of negative 4. Now, when you go g of negative 4, that means that I'm looking, this is going to be my x value, but then I'm going to be looking for my y value. In other words, what is the y value when g is negative 4? So I'm going to come over and go 1, 2, 3, 4. I'm looking for the y value of this graph of when x is equal to negative 4. So I'm going to have to come up, and if you notice, it's going to hit right there. And so that means the value of x then at this point, so this is the point then, negative 4 comma 6, that means g of negative 4 will also equal 6. But look at this is the opposite. So this time they're saying what value of x is going to equal, what is the value of x when the y value is negative 4? So this is my y. So in other words, I'm going to look to see where my y value is, and if I say that, like in this case, I'm going to say that my y value, any of these values here, when x is equal to, then this is the point 3 comma negative 4, 4 comma negative 4, or 5, then I know that my value of g of x is going to be then any point that is going to be then from 3 to infinity. So I can write that as we did last time as an interval notation. So I'm going to start with 3, and I'm going to go to infinity, and I made an error. Do you see what my error is? I always do this when I start doing this. The bracket, you're right. Sorry about that. So yes, I made an error because at that point, it is going to be negative 4, and so it includes that point, and so that I want to make sure I change that to a bracket. Okay. So, obtaining information. You can obtain information about a function on a graph. At the right or left of the graph, you will find the closed dots or open dots or errors. So keep in mind when we talk about that closed dot is going to be the same as our bracket, and then our open dot would be then our parentheses and interval notation. And the arrow is just going to indicate the direction that we have. Okay. Looking at this one, okay, so we're going to identify the domain and the range of f of x. Okay, so then use the set builder notation and interval notation. So let's start off this. Let's go ahead and do the domain. And in this case, we're going to do the set builder notation. So the set builder notation starts with a bracket, and it goes x such that, and then I'm going to look to see what values of x this could be. So if you notice that in this case, it looks like it's going to continue on. I've got probably one of the curves, one of my trigonometric curves, and it's just going to continue on in a direction. So that means that my x value is going to be x as an element of the real. Okay? In other words, you're going to have all real numbers, x can be anything. In interval notation, that would be where we start off with negative infinity, and we're going to go to positive infinity, and we always end with the two parentheses with infinities. Now my ranges are different. Okay, if you notice that I am only going, even though I'm going lots of values for x, I can go anything, but the highest value I'm going to get is going to be 5, but the lowest value I'm going to get is going to be also negative 5. I'm never going to have a negative 6. I'm never going to have a positive 6. So in this case, I want to start, anytime you do your range, you want to start with the lowest amount and move it to the highest amount. So in this case, my set builder notation, I'm going to say that y such that, now in this case, I'm going to have a region. So I'm going to put y in the middle. I'm going to also say that I'm going to start with a negative 5, and I'm going to go to a positive 5. But then I need to put my inequalities in between. Okay, is it equal to, first of all? Will these points be equal to 5 and negative 5? Yes. So in other words, you're never going to get, y is always going to be greater than, or excuse me, negative 5 will be less than y, which is also less than or equal to 5. And then to me, the interval notation is easier to write for me, but remember, it's also looks a lot like sometimes it looks like a coordinate point. So I'm going to go from the lowest point to the highest point. Since it includes those points, remember, instead of a parentheses, I will put a bracket. Okay. This is considered, we're going to work on some piecewise functions, and this is just a section of a graph. And so we start off, what is the function's domain? Okay, and we're only going to do the interval notation in this case. So domain, remember the x values. So if you look here at this point, this x value looks like it's at the point 0, negative 1. And then this point over here looks like it's at the point 1, 2, 3, 3, 5, 6, 7, 8. 3, 8. So when I do the domain, I'm only doing my x values, and so it's going to be from 0 to 3. Now the question is, will it include 0? Yes, but does it include 3? No. So it'll look like this, where it's going to be a bracket with a 0 and a 3 with the parentheses. Now when we do the range, don't forget that that's going to be my y values up and down. So then I'm going to look at the y value here. So my smallest y value is going to be negative 1. My largest net y value, I thought it was 8. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it is. I wasn't sure if I started with 5 as the right spot. So I'm going to go from negative 1 to 8. But now again, I'm going to include negative 1. So that means it's a bracket. But then I will not include 8. So it's going to be a parentheses. When I look for my x-intercepts, remember, anytime you have an x-intercept, that means y equals 0. Anytime you have a y-intercept, that means x equals 0. So when I look at my x-intercepts, I'm going to look for the fact that it's crossing my x-axis, and it looks to me like the y value right here is going to be the place, and so it's actually at the point 1, 0. So when you write x-intercepts, you can say the x-intercept equals positive 1, or I will accept the point also, or at 1, 0. The y-intercept in this case, I have one place where it crosses, and it's going to be the exact same thing because it's this point right here when x is equal to 0, and so in this one is going to be the y-intercept is going to equal then negative 1 or at 0, negative 1. So if you want to put the coordinate, you can. The value of f of 2, so remember that means when you have f of 2, you're looking for, that's going to be the x value, and you're saying what y value is going to be associated when x is equal to 2. So when x is equal to 1, 2, I'm going to come up, and it looks like it's going to be right here at the point 1, 2, 3. So it's at the point then y value is going to be 3. Any questions on that? Perfect. All right, the last group, okay. This one's a really odd graph because all you have are points they're listed. So again, you're looking for your domain, okay, so those are going to be your x values. So on this one, use the graph to determine the following. So in other words, I'm going to write it as a set because in this case I'm going to have different numbers. So in this case I'm going to have 1, 2, 3, 4. This is the point negative 4, 1, 2, 3. And then it looks like I'm going to have the point negative 2, 3, negative 3, etc. So my x values are going to be just the x values of the points that I have. So I'm going to start off with negative 4, negative 2. I also have the point then when x is equal to 0. I'm going to have the point when x is equal to a positive 4 and when a positive 5. And so I'll separate those within just commas. If I look for my range, every point on this one is going to be negative 3, and so my range is going to equal then negative 3. In this case, do I have an x-intercept? Does it cross the x-axis? Nope. And so it's a null set. And then the y-intercept, if any, will be right here. Yep. And the y-intercept equals then -3, or you can write it as the point 0 comma -3. Okay? All right. Thank you. That's all we have today.